and all. I would like to thank the Department of CSE, Wellar College. So it's my privilege to have a session with the college. Even this is my second term. I'm giving the session for the AICT sponsored program. Right. So we will begin with the our uh, agenda of the course. Right, you are able to see my screen, right?
Yes, sir.
Right now. Now, so first of all, I want to give that the basic knowledge about the what's the Merkle tree and why we are using the Merkle tree. That I am going to specifically advise this point. So later part, I'm going to talk about the various types of blockchain having in the market, right? So we came across that Merkle tree whenever we have a diagrams, whenever we are having a block. So in order to give that block kind of thing, whenever you want to join the block, then you are using the Merkle tree structure, which it means that suppose if I'm having a blockchain in the format of, like, so suppose this is my one block, and this is my another block, and this is my another block. Like this way I'm having it. Suppose, so the starting point of the block in any blockchain we called as a genesis block, right? So I'm talking, so this is my genesis block, and the what it is having the several number of transactions in a particular block. Then this block is linking with the another block, and by means of hash, right? I thought that you have some basic knowledge about that one. So if you don't have any idea about this hashing technique and all these things, please ask me in the questions time, then I will respond for this one, right? So we will get a hash value for each and every, what we call as every block. So in the block I may have the several number of transactions. Like if I'm talking about the in the database in a particular table, I may have the thousands of transactions might be stored in the database. In the similarly, each and every block contains the some random number, some number of transactions. I may not say that thousands transactions can be stored in a one particular block. It is not possible. Maybe I'm taking it as an example of 100 transactions can be stored in a particular block. So so after that, if I'm getting the 101 transaction, then that transaction will be stored in the next block. So this is the general criteria whenever we are storing the transactions in a particular block. Now during this point, now how it makes a particular hash value for a entire block. Why? Because I'm having the various transactions. I'm taking this suppose, for example, I'm taking the example of a, I'm having the four transaction called as a b c d, and so for each and every transaction there will be an hash value. So I'm representing with a ha. This is the hash value of the particular a transaction, right? And hb is my hash of the b transaction, and hc is my hash value of the c transaction, and hd, this is my hash of the d transaction. So I will get like this way, right? And then after this, these two hash values will be merged together and will give you a one hash value, that is what we call as an HAB. And the further two things also will be joined together, and it will produce that HCG, right? So after this, these two also will be joined together as it produces the one hash value, so that in the block you will get finally one particular hash for a transactions which is there in a particular block, right? Now this is the block hash. This is the block hash, HABCD, suppose. Now this will be added with the previous block hash. So these two together will form this current block hash. Now this will be forwarded for the next block as a previous block hash. This is the criteria how it is going to be happened, right? So still, if there is any problem to understand this one, please ask me at the questions time, then I will respond for this things, right? Now let I will start with the concept called as a types of blockchain, right? In the market there are various types of blockchains are there, various blockchains are there. I am not talking about the types of blockchain, but various blockchains are available. So Ethereum is a blockchain, Bitcoin is a blockchain, Stellar is a blockchain. Like this way we have a thousands of blockchain technologies are there, right? So these all are cryptocurrencies, right? We are talking about the cryptocurrency, these all things. So whatever the cryptocurrencies are there, behind there is a technology called as a blockchain. All these cryptocurrencies are running for by using the blockchain technology. Now what is the use, as a technologist, for us, what is the use of cryptocurrencies? It's a financial activity, right? So then what is the use means that, so some of the blockchains are allowing us to write our own code and deploy it on the blockchain. That is the major platform. Because of that reason only we are talking about, or we are learning about the blockchain technology, so that we can deploy our own problem statements. I can deploy it on the blockchain. So in this concern, we have a various types of blockchains are there in the market, right? So namely called as a public blockchain, and next is a private blockchain, next is a consortium blockchain. Maybe somebody is telling that the fourth one also hybrid blockchain. Okay, that also we will talk about. Now what is the public blockchain? Whenever we are talking about a public blockchain, so first of all I'm going to take a one particular blockchain network, something like that way. I'm having the, suppose, a 4 node network, a 4 node blockchain network. So simply I'm taking these 4 nodes as this is my A, this is my B, this is my C, and this is my D. So whenever I'm having a 4 node network, then, so if I want to add, anyway, when I'm talking about in the realistic scenario, there might be n number of nodes. That's a different story. But for our convenience sake, I have taken it as a 4 node network, right? Now, if I want to add any other node into this blockchain network, then there is no need to take any permission. No need to take any permission. So that is what we called as a public blockchain. So which it means that, so whenever you want to add a particular node into the blockchain, then no need to take any permission. So you simply download the prerequisites, install it, that's it. So your computer is going to be run as a node. Now the example is that Ethereum is an example of a public blockchain network, right? Bitcoin is a public blockchain network. These all are public blockchain network, right? So here, because of that reason, it is called as a permissionless permissionless, which it means that whenever you want to add a node into a blockchain network, no need to take any permission from anyone. We know that this is a decentralized application. No need to take any permission from anyone. So because of the reason, if I want to add a particular node also, I'm not at all taking any permission from anyone. Is possible, right? Because of that reason we called as a public blockchain network. So it is a permission less. So on the other hand, I'm having a if I want to add a particular node into the blockchain, then I should take the permission. I should take the permission. So I can't add just my node into the blockchain. It is not possible. So this is what we called as a private blockchain. So whenever I am talking about the private blockchain, so there is a requirement of a permission. You have to take the permission, right? So if I want to add a particular node into the blockchain, then I should take the permission from the concerned authority. That is what we called as a private blockchain. The example for the private blockchain is Hyperledger, right? Now, more precisely, so as we understand about the what is a public blockchain, what is a private blockchain. Now, I will give you a generalistic example. Now, if I want to visit any MRO office or RDO office, then no need to take any permission, right now. So yeah, I want to register my date of birth certificate, or I want to get the date of birth certificate or something like that way. Then we frequently go to the public service offices. Then no need to take any permission, right? We can directly go that one. So so remember like that way. So the public blockchain like a public service, so that no need to take any permission, directly we can go it. Right now, suppose if I want to enter into the well or college, then I require some permission, right now. So some person I know that, so I want to meet her, something like that way I have to tell, right now. So then this is a private organ. Why I have to take the permission means that this is a private organization. Without permission you can't enter into that office, right? So that what we called as it's a private blockchain, right? So remember these 2 points now. So basically these are the two things only the available. So one is a public blockchain, which is publicly available. If you want to add a particular node into the blockchain, then you can add directly. There is no need to take any permission from anyone. You can add the node. Whereas in contrast, in the private blockchain, if you want to add a particular node, then you have to take the permission right from the concerned authority. Then only you can add a particular node into a blockchain. So that is what we called as a private blockchain. So basically these are the two different things only available in the market. The remaining all are that what I can do else. These two things, based on that thing only it came into the picture. Now for that, for consortium blockchain, I'm giving the example. Now suppose SBI, State Bank of India, wants to develop for its branches and all these things, they want to develop a blockchain technology, right now, then it is called as a private blockchain. Why? Because it's a personal to the uh, SBI only, right? Then it is called as a private blockchain. Whereas if I want to talk I want to take it as an SBI, suppose ICICI and Union Bank, these three wants to share, or these three wants to work on the blockchain technology, then we called as a consortium. That's only now, sir. So consortium means that the group of people, right? If I'm talking about a private, a single organization. If it's a consortium means that it's a group of organizations, right? So if I want to deploy a blockchain technology for the various organizations together, then I may call it as a consortium blockchain, right? So that is what where we got it as a consortium blockchain. Here also again a consortium blockchain also, it's a private blockchain only. So it's not in the public thing of work. It's also a private blockchain only, but so moreover it is using the several number of organizations. So what is the difference between the private blockchain to the consortium blockchain means that in the private blockchain, I may deploy the project for a particular organization. If it is a consortium blockchain, I may deploy for the various number of organizations. Maybe the few organizations together. I'm going to use the blockchain technology. So that is the difference. Now, I heard about I given the statement that we have a hybrid blockchain also. Then what is a hybrid blockchain? So if I want to go for a, maybe somebody asking us that okay sir, we require public blockchain, some things I should be posted in the public and something should be a private. So in that scenario we are going to call it as a hybrid blockchain, right? So my project resides in the both the categories. I require some of the data in the public and I require some of the data in the where we are concerned about the hybrid blockchain, right? So that what we are calling it as a hybrid blockchain. These are the various types of blockchains are there now. Still, so I want to differentiate between these two things in a regular manner. Like, so I'm taking the public blockchain and as well as the private blockchain. I'm talking with respect to the access. So open read write access, so that I can read and I can write. It's a open. Anyone can read and anyone can write the data. If I'm converting as a node of my system, then I can access it. There is no problem. For reading, it's publicly available. There is no issues at all. So how it is publicly available, that I will show it to you. Suppose if I'm talking about the Ethereum right now, so my job is to explain the Ethereum, so that I'm talking with respect to the Ethereum only. So if I'm talking about the Ethereum block explorer, so where all the transactions are going to be noted down in the etherscan.io, right? So there I'm going for the blockchain and view transactions. If you click this one, then you will get the all the transactions are happening in the real part, right? We didn't get any understanding of these things, right? I couldn't understand this one, what is the transaction hash, and yeah, I can understand about the block right now. Timestamp I can understand it, but I didn't understand about the from address, whose that address is that. Right now I couldn't understand about that to address right now. So these all things I couldn't able to understand these things. Okay, that's a different story, right? So now what I'm going to talk about here is that now for this, so there's what we called as an it's a open, it's a open, it's a open to read write. Why? Because Ethereum, I informed you that Ethereum is a public blockchain, right? Whereas in the private blockchain, so it's a permission read and write access. So suppose if four members are there, one two three four, now four is not having any permission to write, then he couldn't able to write the data into the blockchain right now. So like that way, so we are restricting in the permission blockchain. It is possible, right? Suppose if I am talking about the speed, right? So since it is a public blockchain, there are thousands of nodes are available in the public blockchain network. Because of that reason, the system might be slower, right? The entire transaction should be submitted and it should be confirmed. I think so that you have already discussed about the consensus algorithm or something like that way. So that it was confirmed. To get the confirmation, it will take some time, maybe the 10 minutes or 5 minutes, like that way it will take time, right? So that is the in the case of public blockchain. Whereas, so there are only the few members are there right now. Whenever I am talking about the private, how many are there? Maybe the 10 users or 15 users or 20 users or 50 users right now. So very minimal users are there. So to get the authentication is very easier. So that because of that reason, the speed is very fast when I'm talking about the private blockchain, right? And when I'm talking about the security concern, how the security is provided in the public blockchain means that by means of the consensus algorithm. I think so that you already understood about that POW, proof of work, and proof of stake algorithms. You might be discussed about that one. So that based on those algorithms, the public blockchain network is going to be provide the security right now. And in the private blockchain, the pre-approved process participants are there. Those will be the security concerns right now. So they have to authenticate the particular transaction, otherwise it can't be done like that way right now. Suppose uh, for our university, suppose right now 70% only, so 30% we want to decrease the syllabus because of this pandemic. Now, who has to decide? That will be the university head, like a vice chancellor will decide that how much syllabus they have to conduct in during this pandemic time. Right now, he is the authorized person, so that he is having that security concern. That suppose if I'm posting like that way, right? So I'm decreasing the syllabus for 30%, right now. So which is not valid, right? So whenever an authorized person, they only can give that information right now. So that is the security concern right now. Identity, so which it means that, so whenever a public blockchain I'm taking it, the identity is anonymous, which it means that you can't understand it right now. So that only I'm showing it here right now. Now I'm talking about this is my transaction, who is sending this some value, right? This is the person is sending it, that we can't understand that who is that person right now. Why India is against to the cryptocurrency so far? Because of this what we call as a identity based. So nobody knows that who's that account is, who's that account holder is right now. So because of that reason, so what we call as a Indian government is not accepting to enter this cryptocurrencies. I'm talking about the cryptocurrencies, not the blockchain technology. Please see, these two things are clearly there. There is having a much more difference. Different things are there. Anyway, in the later part, I will give you some glimpse about that point also, right? So I'm so whenever I'm having an address, then this address cannot be understand that whose address is that one, that I couldn't able to understand it. So that's what we call as an, it's a pseudonymous or anonymous address, right? And here in the private blockchain, yes, it's a known identities right now. So suppose somebody is sending the transaction, then okay, among the 10 we can easily identify it, this is the person who is sending the data right now, that we can easily understand it is possible, right? Now I'm talking about the asset. So which it means that, so whenever I'm having a public blockchain, there is and some asset is there. That asset only we are calling it as a cryptocurrency, right? So sometime we called as a, if it is a bitcoin technology, then the asset is called as an bitcoin. If I'm talking about the ethereum technology, then the asset is you called as a ether, right? So so that is what we called as an the asset. But whereas if I'm talking about the uh, uh, what we call as a private blockchain. So private blockchain is not at all be right. There is no asset for a private blockchain. Why? Because if I'm taking the privately assigned data, then there is no requirement of the thing right now. So because of that reason, there is no asset for a private blockchain technology, right? And if I'm talking about the privacy, how the data is like giving the privacy for this one means that based on the what we call as the metadata we are publicly available, but the identity is not at all understandable right now. We know that, right? So it's a privately available, publicly available, but it cannot be understand right now. So that is the what the issue in the privacy. So and here the privacy policy is the based on the what we call as in the traditional database, how the traditional database having the privacy. Suppose if I want to restrict a person or group of persons from the network to access a particular functionality, that I can do it, right? So in the database, the similarly we can design a private blockchain according to our usage is possible. Now there is a transaction fees for a public blockchain. Why? Because we have a transactions, we are doing it in the publicly available, and there is some criterias are there why we are maintaining the transaction fee, that I will talk about the transaction fees in the Ethereum part, right? So we require some transaction fee in order to do the transaction, that I will observe it that point also. So this is what I have shown to you right now. So this is my transaction, it is showing me some transaction fee here. So it is showing some transaction fee here. So there is a transaction fee is available for each and every transaction, whatever you the transaction you are doing it, right? So in the public blockchain, whereas it is a private blockchain. So to pay this transaction fee only, we require an asset. Why asset? What is the use of asset means that? So they have to pay in terms of some asset, right? Na? So that asset with respect to the Ether for the Ethereum blockchain, for doing the Bitcoin transactions, then you have to pay some Bitcoins, right now. So this transaction fee is there. Because of that reason, we have some asset. I have to pay something, right? How I have to pay? In terms of Bitcoins or in terms of Ether, that I have to pay it, right? So that only it is going to be happened. Now, whereas if I'm talking about the private blockchain, it's a completely free. Why? Because if I'm deploying for my college, then or for my organization, then what is the use of collecting fee for a transaction? There is no mean, right? So because of that reason, there is no fee in the private blockchain. And immutability. So the immutability will be achieved through the hash power. Right now, hashing concept, I think so that you have discussed it in the previously in the previous sessions. I think so that if there is any doubt regarding that point, please ask me at the questions time, so that I will answer that questions. I hope that you know some knowledge about the hashing things, and I think so that even in the Merkle tree point of view also, right? So because of the hashing power, so the immutability comes into the picture, right? So and here it's a security distributed consensus. So it is a distributed consensus are there in the like in the private blockchain. Like suppose if I am taking it as four members are there in the group, if majority of the persons are accepted for a one particular rule in the particular college or in the particular organization, that will be finalized, right? So in the same way, so whenever a transaction is going to be like confirmed, then this process will be this process will be done in the private blockchain. So like that way we are achieving the immutability. Now the examples what I said earlier, that the private blockchain Bitcoin is an example, and for and as well as the Ethereum is an example. There are so many public blockchains are available in the market. Whether they are allowing us to write some program or not, that's a different story. And for the private blockchain, there is a good concept called as an hyperledger, right? Now if I'm talking about the, as I mentioned, that Bitcoin, Ethereum, and Hyperledger. Every time I'm using these three terminology, right? So I want to differentiate between these three. Right? What is a Bitcoin? What is an Ethereum? What is an Hyperledger? That we will see. We know that Bitcoin is a public blockchain, which is a private blockchain, right? Permissionless blockchain, and Ethereum is a permissionless blockchain again, and whereas the Hyperledger is a permission blockchain. Right now it is a public, and Ethereum is also public, or you can define a private Ethereum network also in the recent days, right? And Hyperledger also is a private, we know that, right? Now the consensus mechanism we are using in the Bitcoin is a proof of work, Ethereum is using also using the proof of work. They are planning to change from the proof of work to proof of stake. This I'm hearing the same word since 2.5 years, but they haven't done it. So right now they are in the proof of work only still. So and in the hyperledger we called as an PBFT, practical Byzantine fault tolerance, right? By using the that methodology, hyperledger process, hyperledger consensus mechanism is happening it. And scalability, which means that how many systems I can connect. So you can connect the high node scalability. So there is no restriction that only 10,000 systems only connected or 1 lakh systems are connected. Not that way, right? Whatever the number it is, you can connect it, no problem. So because of the high node, automatically the performance will be decreased, right? If I'm having the high node, automatically the performance will be decreased, right? Now, because of that reason, in the public blockchain, high node scalability is there, whereas the low performance scalability is there for Bitcoin and as well as the Ethereum also. Whereas for the Hyperledger is a private blockchain, as we know that, so that it's a low node scalability, which it means that I can't connect it like a 10,000 systems for SBI. It is not possible, right? So like this way, there is a low node scalability, but high performance scalability is there when I'm talking about the Hyperledger fabric, Hyperledger, right? And the native currency, yes, there is a native currency is there, that what we call as a Bitcoin in the Bitcoin. And for Ethereum, yes, Ether we called as a, since it is a private network, there is no requirement of a currency. So for my purpose I'm defining it right now. So for that reason no need to take any asset or native currency. Because of that reason Hyperledger is not having any native currency, right? And this is a scripting, which it means that whenever I am writing, if I want to write my own code in a particular blockchain technology, then if I am talking about the Bitcoin, as it is a limited possibility, I should say that there is no possibility to write your own code and deploy it in the blockchain is not possible, right? Whereas if I'm talking about the Ethereum, so there is a high possibility of writing the code. Why? Why Bitcoin is not possible and why not Ethereum? That I will confirm it. Before going to do explain about that point, what I want to tell you is that first of all I want to give that what is a blockchain and blockchain technology. Why? Because we all frequently, even in the beginning days, I am also confusing that yeah, but sometimes they are calling it as a blockchain technology, sometimes they are calling it as a Bitcoin or Ethereum, like that way they are calling it as. So what is these things, like that way I used to confuse, right? So for that reason, what I want to give you here is that the difference. Now, a blockchain technology was developed. Who developed it? We know that Satoshi Nakamoto, the founder of the Bitcoin. Right now, it's a pseudonymous. We know that, right? It's a pseudonym. We don't know that whether it is a male or female or no one knows, right? So this is a blockchain technology which is developed based on the, right? We know that decentralized, uh, decentralized, distributed, immutable, ledger technology, something like that. We used to call it as right now, ledger technology, right? So this is the platform which they have developed, right? After this, on that, by using this blockchain technology, now the sum of the people, they find their own frameworks, their own frameworks which serves some purpose, right? So like that way we have a Bitcoin is there, right? And then Ethereum is there, Ripple is there, Stellar is there, like that way n number of applications are developed, or frameworks are developed on top of by using the blockchain technology. Now among these all technologies, few of them allow us That means allow a common user or a developer to develop and deploy it on this platform. So which it means that, suppose if I'm talking about the Ethereum, so Ethereum is allowing us, to write our own code by using the Ethereum blockchain technology. I can deploy it, my own application. So is possible. So that is the application of the Ethereum, right? So that what we called as an Ethereum, right? So like this way, there are some more other technologies are there, but the most famous one in the real world scenario is then Ethereum. Ethereum is the very famous one in order to do this work, right? Now that is about the that is the total concern about the how the blockchain we have to see. Right now, where we have stopped that concept, what we are discussing previously of this topic is right, yeah. So we know that we all know about the flat subject, formal language and automata theory. Right there we studied that Turing machine. Right now, Turing machines. So I'm taking this Turing machine only. I'm talking with respect to the complete Turing machine. So whenever I'm calling it as, I don't know the exact meaning of what is a Turing machine and what is a complete Turing machine. But so if any particular platform, any framework is a complete Turing machine, which you can able to write the looping concept. Because of that reason, you can define a language on top of it, any programming language on top of it. So if any framework is a complete defined as a complete Turing machine, then it supports the looping concept. For that reason, I can write some language on top of the particular framework. So Bitcoin is not allowing us, it is not a complete Turing machine. Bitcoin is not a complete Turing machine. Because of that reason, we cannot able to write our own code by using any programming language. So that is the difficulty. Whereas if I'm talking about the Ethereum, yes, Ethereum is a complete Turing machine. Because of that reason, I can write my own code by using a language. Now the language was defined for Ethereum is called as a Solidity. Okay, that will be discussed in the 2 mass sessions. That will be different story, right? So that is why we are discussing about the Ethereum now. I can write my own code by using the Solidity language, right? Now, so of it's a Turing complete machine, right? So because of that reason, I can write the programming language by using the Solidity, right? And the hyperledger also, it is also a Turing complete machine. Because of that reason, I can write the code. So here in the hyperledger, we called as a writing the program called as a chain code. So the chain code can be developed by using a Go language, and JavaScript also they can be used, and Java also they can use. Recently they are using the Node.js also to write the chain code. But among these things, market majorly working on the Go language only. When I'm talking about the Hyperledger code was developed by using the Go language in general scenario, right? So that is about uh, the various types of blockchain technologies are available in the market, and the differences of these things, right? Now, so I want to give you a quick glance about the generations, right? I may have that whenever we called as a computer kind of thing, then definitely we called as a generation. So we know that it was started, the blockchain technology all it started from the 2008 by invention of the, or by starting of the Bitcoin network, right now. So because of that reason, so only there is a possibility of the only the currency in the blockchain 1.0, it is having only the It's a only the financial transaction, not more than that, right? So that is what we called as an blockchain 1.0. Whereas if I'm talking about the uh, what we call as a second generation, so there is a possibility of writing a smart contract right now. So by the inception of the Ethereum, then it is a possibility of writing the smart contract is possible, right? So because of that reason, we called it as a smart contract generation is the second generation. In the third generation, we called as a, we can write it as a complete dApp. So I can develop a decentralized application, like by using the front end and as well as the back end all together, we can write a blockchain. So it's possible. So that's what we called as a, there are various types of blockchains, or we can segregate it in the various generations like that way, right? Now we will talk about the Ethereum now. So what is an Ethereum? Ethereum is a, we know that Ethereum is a public blockchain technology, right? So whenever I am taking it as a, it's a public blockchain technology, then so for some time I used to like talk about the Ethereum fundamentals and all these things. So be patient, right? And please try to understand it, right? Now it is a transaction based state machine. What does it mean? What does it mean? A transaction based state machine, which it means that whenever a transaction happens in the Ethereum, then right in the current state of the position 2, it will change into the next state. How how that we will see. We know that Ethereum is uh, a decentralized application kind of thing right now, decentralized and distributed. We know that there are n number of users are there, right? We know that this is maintaining the ledgers. Now what is this ledger, Sandy? Right, suppose A is having 15 ETH. I'm talking about the ethers, right? So B is having suppose 10 ethers, right? C is having 25 ethers, and D is having suppose 5 ethers. Now I'm doing a transaction. What is the transaction? C to D, I'm transferring it 5 ethers right now. Now before that, now this is my current state, right? This is my current state, which it means that the same data will be having by A and by B, by C and by D also, right? Whenever this transaction was done successfully, then what is the current scenario? Now A is 15 as usual, B is 10 as usual, C is 20 and D is 10. Now this is my current state, right? This is my current state. Now so which it means that this is a transaction state, that is what we call it as a transaction state, right? Now this happens so that the same thing will be handled by updated their transaction states, similar way of this table right now will be updated by each and every node in the blockchain network, right? That is going to be happened in the case of a transaction based state machine, right? Now so what we are talking about that only. So if I'm having a transactions, then from one state to other state it is going to move. So the starting position, what we called as a genesis state, where we are starting our journey, is called as a genesis state. So from that point onwards, if the transactions are happened, then automatically from the genesis state to it will go to the next state. And if some transactions are happened, then it will move to the genesis state to the next state. Like that way, it will proceed into the next states. Right now. So whenever I'm talking about the blocks, a block consists of several number of things. Majorly, a block consists of a header, block header, and the transactions. So these two together we have a block right now. So we will discuss about the later part about the block again. So we have to discuss all these concepts like I have to discuss about the accounts, I have to discuss about the state, gas and fees, transaction blocks, transaction execution, mining, proof of work. I think so that I thought that mining and proof of work might be you have finished in your previous sessions, so that I may not touch those points. Right. Anyway, accounts. So whenever I'm talking about the account with respect to Ethereum, now there are two different types of accounts are there. One is called as a externally owned account, and the second one is called as a contract account. Right, first of all, each account is having a handled by using a 20 byte address. Right. Now in Ethereum, I'm talking about the Ethereum, right? So whenever I'm having a externally owned account, what does it mean? So whatever the account I'm having it, that account, what I call it as a externally owned account. If I'm having an account, that is what we called as an externally owned account. So whenever I'm talking about externally owned account, so it is controlled by the private keys. Why? Because I'm controlling my account by using my private key right now. So you have your Gmail account, then Gmail account is going to be maintained or controlled by your private key right now. So it might be we called as a password or something like that way, but it's a private key enabled, right? So and it is going to be having like a no code associated with them. So whenever I'm talking about the externally owned account, there is no code associated with the externally owned account. Why? Because it's my account, no need to having a some code on this particular account, right? So this is what we call an externally owned account. Now the next is a contract account, which it means that, so what is the meaning of contract and the, so whenever I'm having a program, if I am writing it, so in future what we are going to do here, I'm going to write some program. This program I'm going to call it as a smart contract, right? This contract I'm going to deploy it in the blockchain. What type of blockchain this one? This one is an Ethereum blockchain. This is my Ethereum blockchain, right? So whenever your contract is deployed in the in the Ethereum blockchain, then it stores in some address. Right now, it will store in some address where this value, this contract was stored. That is called as a contract account. So where this contract, this smart contract was stored in the blockchain, that what we called as an contract account. So, so a contract account where it is going to be controlled by their contract code. We know that. Why? Because whenever I'm talking about the contract account, a code is there associated with this one, right? So because of that reason, we called as an contract account is controlled by code, and some code is there right now. So some code is there right now. So whatever I am telling it now, this contract was deployed it here. Because of the reason, there is a code associated with that one right now. So in Ethereum smart contract, whenever you deploy it in the blockchain, there is a code associated with this one. So because of that reason, it is the code associated with the smart contract. That's good. Now, more precisely, still I am going to still I will discuss about the contract account and even EOA in the tomorrow session also, like how it is going to be an evaluated and all these things. So I will give the thought also. That's a different story, right? So whenever I'm talking about the EOA, which it means that I'm having my own account right now, that only we called as an EOA. Right now, if I'm having the EOA, what I can do it, I can deploy a smart contract into the blockchain. So which it means that I can communicate from EOA to CA is possible. And the second scenario is that I can transfer something. This we are going to do it in the practical scenario in tomorrow, for tomorrow class, right? So suppose Kadir sir is there, right? This is a Kadir sir and this is me, and I want to transfer some value from my account to Kadisar account is possible. Is possible. Which it means that I can do the EOA to EOA, which it means that I am sending from my account some value from my account to your account is possible. But that is what we called as an EOA to EOA is possible. Externally owned account to externally owned account is possible, right? That what we called as an EOA to EOA. Whereas I can do that EOA to externally owned account to CA. Why I have to do this one? I want to deploy contract into the blockchain. Right now, my own code, I want to deploy it in the blockchain. Yes, it is possible. Right now, these two things are possible, right? So one is an EOA to EOA and second one is an EOA to CA. Right? These all things are the same thing. Now that only I have informed you that EOA to EOA is possible. That what we call as a value transfer. That is what we call as an a value transfer from EOA to EOA is possible. Now, whenever you are doing it, the transaction, so the transactions are going to be noted down in the blockchain. There is no issue at all, right? All these, whenever you are doing some transaction, then the transaction is going to be noted down in the blockchain, right? In the block, right? All the things are going to be noted down there, right? So now, whenever I am talking about the contract accounts, then from the externally owned account to I can deploy the contract accounts, right? It is possible, right? And then after that, now the contract account may communicate with the another contract account is also possible. How means that if you are deploying a program right now, that program may communicate with the other program. We have a sub programs concepts are there or functions are there, something like that, right? So in the similar way here also, whenever you are deploying it, then definitely an a contract account may communicate with the or may do some internal transaction to communicate with the another contract account is possible. There is no issue at all, right? Now, so there is an account state. Now these are the accounts. So whenever I'm talking about the accounts, I'm having the two different types of accounts are there. One is the externally owned account and second one is a contract account, right? Now if I'm talking about the account state, each account, it may be a externally owned account or contract account, it is having some states. So in the states I'm going to talk about the nonce. Nonce in the blockchain technology, you are going to come across in the two places. One is in the generalized blockchain, how the hashing and how the security is going to be implemented. There you will get some nonce in order to decide the block difficulty. Right there, you will get that point. So I'm giving that chance to you that if you are not aware of that point, I will discuss that point in the questions time, right? So that is a one nonce we called as a, there we called as a random number, and the second nonce is this one, which it means that it is what we call as a number of transactions, how many transactions are happened, that it is handled by the nonce in the account state. So which it means that if the account is an externally owned account, right now we know that two accounts are there right now. So for the two accounts I'm going to talk about, for the externally owned account, this is the number of the number represents the number of transactions sent from the account's address. So suppose if I'm doing today 10 transactions, then nonce is 10, right? That what we called as a nonce. Now if the account is a contract account, the nonce is the number of contracts created by this account. So whenever it is a contract account, then how many contracts it was created, that was given by this nonce. Right now, after the nonce, I am having a balance. How much balance you have it in your account? Tomorrow I will show you that the installation of MetaMask and all these things. Now this is my EOA. This is my EOA. I'm having some ethers. I'm having some ethers, right? So this is the balance which I'm having it right now. So a balance is that how much V's, how much V's, what is a V also, that I will discuss in the later part, right? How many V's owned by this address right now. So I'm having some value right now, and the storage root, which it means that the hash root node of the Merkle tree, that only I have discussed it in the earlier, that what I have given this one is the point is that, right, this is the Merkle root. This only I'm talking about this, which it means that I'm having the various transactions in the block. All these blocks, every transaction in the block having the hash value, all together you will get the one hash value. That is what we call as the storage root. So that is what we called as a storage root. So totally you got it as a one hash value in the particular place. That's what we call as the storage root. And the next one is a code hash, which means that, so for the code also it will be converted into the hash value which is maintained by the EVM. So if I'm converting my contract, then it is having it like that way. Then if I'm not converting my code, then again somebody will steal my data. So there is a difficulty. For that reason, I'm doing it code hash for this data also. Right now, that is also possible. Right? These are the various components in the accounts. So because of that reason, it is called as a code. Sorry, account state. Right now, so account state consists of a nonce, balance, storage root, and code hash. Now, each and every block is having a concept called as a state tree, right? Transaction tree and recipient tree. What is the tree here? It's a Merkle structure right now. So what are the different states are having it, and again it will be having a single value. That is what we call the state tree. For the transaction, what we talk about the Merkle tree is a transaction and recipients tree, which it means that whom I am sending it from this entire blocks of transactions. That's also having the recipient tree. These all things having these values, right? Now there might be a full node and light node. This I will talk about in the later part, full node and light node. Now, come to the gas and payments. What does it mean? Now, whenever I am doing a transaction, then I have to pay something. Right now, that only we discussed it right now. So, suppose if I am talking about the like a transaction, so this is a transaction fees. How I am paying it in terms of gas. Then what is the gas? Right now, so suppose if I am talking about the gas, now suppose if I am writing a C program, then whenever I am writing a C program, then I can write in the like a minimal kind of thing. What is the need of writing a minimal steps of code? Means I don't want to waste the I will calculate the time complexity and the space complexity, where I will get the lesser time complexity and space complexity. There I will take it into my consideration. That is a usual scenario, right? So in the same way here also we are going to talk about the we are paying in terms of gas for execution of my contract. Right now it may be a value transfer, or it may be a what we call as a smart contract execution, whatever it may be, that one when you are deploying your transaction, then you have to pay something. So that in terms of gas, which I usually give the example like gas is like your fuel, right? Gas is your fuel. Now, suppose you have a car, right? Now you want to travel, suppose 90 kilometers. You want to travel 90 kilometers, right? Now, so your car is giving 20 kilometers per liter. Now, so when you want to travel this 90 kilometers, what you will do? You will fill your tank at least 5 liters, right? To travel 90 kilometers. Now, so which it means that suppose in our case, now you want to do this transaction. To do this transaction, you require some gas, right? Up to here, clear? Now, so now how you are paying for this 5 liters? You are paying with respect to the rupees, right? Right? You are paying with respect to rupees. Now, suppose I am taking it as a 100 rupees per liter, then you are going to pay 500 rupees, right? Sooner or later, maybe we are going to reach this 100 rupees. So that don't worry. So I am not giving more amount, but definitely, maybe the next year we will definitely touch this 100 rupees. No problem, right? So, that we have to pay the 100 rupees right now. So here also, this is the gas which I require it to travel this one, right? To complete my transaction. For this thing, I have to pay in terms of ethers. In terms of ethers, how I have to pay this gas fees means that in terms of ethers I have to pay. That is the scenario, right? I hope you understood this point. Now, so what I'm talking about here is that, so this fee is paid in the denomination of the gas called gas. So gas is the unit used to measure the fees required for a particular computation. So whatever the computation you are doing it for transaction, that you are going to calculate with respect to the gas. How many gas units are needed to complete the particular computation? That only it will calculate. The system will calculate. We are not doing it right now. Just we are providing the money right now. Gas price is the amount of ether you are willing to spend every unit of gas, that in the measure of GUI. GUI is the one of the unit of the ether that I will discuss in the later slide, right? Now, what is this one? Now, ether, we know that. Do you know that what is the ether cost today? One ether cost today? It's around 87,000. Today, one Ethereum, one ether cost today is 87,000. Do you know that what is the cost of Bitcoin right now? It's a 28 lakh, I think so, that if I'm not wrong, nearly 28 lakh. So I'm having my online application also. Why? Because I used to purchase cryptocurrencies and selling thing also. I can do. I am doing it. Okay, that's a different story. But the approximately that around 28 lakh one Bitcoin costs. You know that where it starts its journey in 2009 for a, suppose I'm taking it as a $1. In 2009, it started its journey. $1 right now it's a $37,000. Imagine how much it was increased. Okay, that is not our concept. Why? Because we are not discussing about any cryptocurrencies concept, right? Which we are the technologists. We don't want to earn money, but we want to earn only the knowledge, right? That is our motto right now, right? So that is one ether. So in that one we have a, like a, I'm having a 1 rupee. In that one, the what is the smallest divisible part in 1 rupee? So 1 paise is there right now, right? Whether it is existed in the market or not, that's a different story, right? So whether can we use one paise for some purpose? no. Even we can't even 25% also from the market it was wiped off, right? Only 50 NP also, more or less we are not able to see that 50 NP also. Right now in the ether, if I'm talking about the ether, there are a few parts also there, but I'm going to majorly focus on GUI and V. What is that one? GUI and V. So the V means that one ether equal to 10 power 18 V. This is the smallest unit, right? And the same time, one ether is equal to 10 power 9 GUI. Right now, remember these 2 points, it's enough. There are so many things are there, but not required. V, GUI, and ether. Enough, right now. So, so now, so we are paying with respect to V, they are calling it as a right now. So there is no issue at all. Now, how we are paying it? Right, suppose I'm taking it as a gas limit. I'm taking it as a gas limit. Suppose if it is a 50,000, for 50,000 I have to pay something right now. So how much I'm willing to pay means that 20 G per each gas, which if you calculate that 50,000 into 20 G right now, which it is cost you that 0.001 ethers, you have to pay it. If it is a 50,000, you are ready to pay for each gas. You want to pay 20 V. Why you have to pay more? Why can't we pay it as a V? Means that if you want to execute your transaction fastly, then we are paying more, not more than that, right? So that is the what we are paying it, right? Next is that I'm talking about the how we are paying it right now. So I'm taking the two scenarios, right? One is that I'm paying from the sender to receiver. So if I want to complete my transaction, I have to do the two steps, right? Now to complete the two steps, it requires some gas, right? Now I'm providing a 250 gas, right? Now the transaction was started. To complete this transaction, it consumes the 50 gas, so that leftover gas is 200. Now I have completed the another transaction also. It requires 20 gas, so that leftover is 30 gas, so leftover is 170 gas. So you came to the end. Then so after that the Ethereum network will be resend your back the remaining amount to your account. So when 170 is going to be returned, so return to your account, which it means that you are going to the shop, you went to the shop, so you have purchased 200 rupees, you have given to him that 500 rupees, so that he is going to return the 300 rupees, right now similarly, no issues. So if you are providing more fee to the network to do your process, there is no issue at all, no problem. Right now there is no issue at all, but there is a problem with the if you are sending less gas, that I will take in the example. So suppose if you are taking this now you are the sender, right? Suppose you are having a 250 gas as usual. Now you have to complete the three transactions to complete your work, or three computation. This is the computation 1, this is the computation 2, this is the computation 3, then end of transaction. Think like that way. So your transaction has to complete three computation. Now for this computation it requires suppose 125 gas. Now you remind 125. Now you require here suppose 100 gas, so that 100 gas is consumed, remaining gas is 25. Now it requires suppose again 100 gas, but only the 25 gas is there, so that it can't be complete this computation. So generally, what we are doing it in the beginning time onwards, whenever a transaction completes, then it moves from the current state to the next state, right now. But in this scenario, is the transaction was completed? No. So that this particular scenario we called as a out of gas. You may call it as an exception or something like that way. It's a out of gas situation, right? Now what happens when it is having the out of gas? Now which it means that you went to the shop right now with 500, but you have purchased luggage like groceries for 700 rupees. What he will do it? What the shop owner will do? So he will take his items back and he will give 500 rupees right now. But here they won't return anything. They won't return anything. Why? Because it's already consumed, right? It's already consumed. Again, it's already consumed. So none of the gas was returned to the sender. Moreover, this transaction is not completed. Because of that reason, your transaction going to be stay in a previous state. So that happens when it is out of gas, which it means that whenever you are providing the gas, you provide the more gas. If you are providing the more gas, nothing will happen right now. Whatever the required gas is there, that will be consumed by the network, and the remaining thing will be returned back, no issues. But if you are providing the insufficient gas, then automatically there will be a problem. Right now, please observe carefully. So there is what we call as an out of gas situation considers to be invalid. In this case, the transaction processing aborts in any state that occurred or reversed, right? Such that we end up with the back to the state of the Ethereum prior to this transaction. So whatever the transaction is there, then it is going to be returned back, and none of the gas is refunded to the sender. So nothing, you won't get it right now. So this is the gas and payment situation, right? Now, what is the requirement of like a gas and payments? Why we have to pay it? Means that there are two aspects are there. One is that if I'm not having any fees, then what we think that in Gmail we have a 5 GB of free memory right now. In our Gmail, for every Gmail account, there is a 5 GB of free storage is there. So I use it to store. I want to use that 5 GB by because it is coming for free, so that I'm consuming it. So if it is reaching to the 90% or 90%, 95%, then the Gmail asking me that okay, do you want more space? Already you are consuming the 95% of space. So do you require any more space, like that way they are asking it right now? Then we usually realize it. Okay, I have to pay. No, I won't pay. So whatever the extra files are there, not necessary files are there, I will delete it and I will keep it quiet. Right? We never pay for storing of the data, storing data in the Gmail, right now, because our intention in general, like that, if it is coming for free, then I will utilize it. If I want to pay, then I will think that okay, is it necessary for me or not? That we will think it, right? So here also, if I'm giving a free, if it is a free, no need to pay anything. If you are doing your transaction, then what we will do, we will like store all our stupid data into the blockchain, which it will give the more burden to the blockchain right now. So because of that reason, what we called as a, we are not at all going to give that more data into the network. So in order to prevent the concept, what we called as a overtaxing, what we called as a overtaxing, we don't want to push all of our stupid data into the blockchain. So because of that reason we are doing it. Now if there is no fees, then what a malicious user will do, he will keep on try that by various methodologies. He will keep on trying to disturb the blockchain network, right now. So that is the major thing what a malicious user doing it for every network, right? Now suppose if I have to pay something to do that work also, then he can, how many times he can do it? 10 times, 20 times by paying it. After that it is not possible, right now. Generally a malicious user will try lakhs of times frequently, then only he can crack it. So if there is a fees, then automatically they couldn't able to do that one. So for that reason also, that what we called as a DDoS attacks, distributor of denial of services attack, to prevent that one also we are using the tax that the fees concept, right? So majority of the networks having that fees concept, right? Now the next one is an execution model. So the in generally whenever we are talking about the Python or Java, we have an Python virtual machine or Java virtual machine. Right now it is running it right now. In the same way here also we have an Ethereum virtual machine. So whatever the process is doing by the Ethereum is concerned with the Ethereum virtual machine only. All the process is going to be managed by the Ethereum virtual machine for us, right? Right. So, and then EVM having its own code in the own language, that what we call as the EVM bytecode, that I will show it in the well in the tomorrow's class. Then how the Ethereum what we call the EVM code is there, bytecode, that I will show it to you. Right. Anyway, so this is my part. Right. If you have any queries, I'm giving the lot of time to you to ask some queries so that you can clarify your doubt. Maybe it will be helpful for you in your research part and all these things. Right. If you have any questions, then you can.
Participants, if you are having any questions, kindly post it in the chat box or unmute and ask. So no questions as of now, it seems.
Yeah. If you have any questions, please let me know so that I can clarify your doubts.
Ma'am,
Hello.
Simi ma'am asked, she wants your help for doing the research.
Pardon, ma'am.
Sir, kindly see in chat box. Sir.
Wait a minute, ma'am. Sure, ma'am. Sure, ma'am. Yeah, I will give my details, ma'am. No problem. You can collect it from Lively, ma'am, right? So that you get the details. So you can contact me anytime. No problem, ma'am.
Any other questions from participants? No questions from participants.
The area is access control. Okay, authorization. Okay, nice, ma'am. Nice, nice. So you're talking about with respect to the blockchain, right? Simi, ma'am. I think so that you're talking about the with respect to the like blockchain. You're talking about the access control, right? Right. No problem, ma'am. No problem. No issues. We will have a discussion. No problem. I will support you, ma'am. No issues.
Any other questions from audience, participants? No, sir. No questions.
Yeah, shall we wind off, ma'am, or shall I take any other things to explain?
Um, no problem, sir. Or we will continue tomorrow, sir.
Okay, ma'am. Okay, ma'am. Thank you, ma'am. Thank you, participants, for your patient listening. Thank you. Thank you very much.
Okay, sir. So thank you, sir. You gave us a lot of information regarding Ethereum and then about various concepts in blockchain. So participants, so we will wind up today now, and tomorrow at 10 a.m. sharp, we will continue with the other concepts of blockchain. Thank you all. Thank you, Ramkumar sir.
Thank you.
Thank you, sir. So I put the link now. Kindly wait. Thank you all. Thank you.